All right, so if you're not here, you're watching the video, or if you're going to watch the video later, I have some challenges with the video that need to get fixed after class. So particularly if you're somebody who's absent watching it tomorrow, when I do my class, I do the same class tomorrow. I'll be able to do all the stuff on the overhead on the screen. So that doesn't mean anything right now, but we have to have a couple of things on the computers updated. So what we're going to do today, we did 1.1 last time. We solved equations. Okay, so hopefully something that wasn't super new to you, and you got to have practice, and you got to do your My Math Lab. If you had any problems logging into My Math Lab, then please let me know so that I can be most helpful to you. We can go find a computer. We can do it right here and get you logged on so that you're not missing out on anything. What we're going to do today is we're going to get through section 1.5. It's not going to take us a super long time because it's a little bit more of the same. The biggest thing we're going to spend time on in section 1.5 is notation. And then we're going to come back and then we're going to do section 2.1. We're going to get as far along into that as we can. And that's where we'll begin to see, I mean, some of you, you're going to see it, seen it before. Others of you, this is going to be stuff that is going to be new. So what we're going to do in section 1.5, far down this line, here, okay. And then how far down here can I go? So what we're going to do in section 1.5 is we are going to solve inequalities. Let me be specific. We're going to solve linear inequalities. So this is one of those things that I mentioned last time. This class keeps snowballing and building up on itself. So if you did your homework, if you feel pretty steady and secure solving equations, now we're going to take those tools and we are going to solve inequalities. So this is our next thing. So don't let this class get too far away from you, especially at the beginning. I want your first test, whatever day we have it on, to be an amazing experience. I want you to come in feeling confident. I want you to get a great first grade so that you have plenty of wiggle room as we go through the rest of the semester. So we're going to solve inequalities. But first, what we have to talk about is how we are going to describe our answers. If you remember when we talked about equations, we use sets to describe our answers. We use some little squigglies, some braces, and we put the number or no solution into those braces. But for inequalities, we're going to have more than one answer. So I've got several examples. This is the big part, the new part today. So here's the types of things we're going to see with inequalities. So I've got something like x is greater than or equal to 2. And then in your notes, if you could leave a little gap, because we'll come back, we're going to do a couple of things with this. I'm just going to write down all the examples we're going to use here at the beginning. Then I've got -6 is less than x is less 3 to the 14. 0 is less than or equal to x is less than or equal to 9. And I think I'm only going to be able to fit 3 on here, but that's okay. Then we'll come back and erase and we'll do the rest. And then x is greater than 6. So these are going to be things that you see with inequalities. These are inequalities in case you haven't seen them before. This symbol right here means that the thing on the left, the x's, my values, are going to be bigger than or equal to 2. That's a greater than or equal to symbol. I'm assuming you've seen this before, but just in case you haven't. This is a bounded inequality, so it has a lower end and a higher end. Okay, so the x being in between means my x's are between those two values. And then this is related to the first one. This is called a strict inequality. It's just greater than. It means your values, your x's, are strictly bigger than 6. Okay, it doesn't include 6. So what we're going to do first is I'm going to start somewhere that I'm pretty sure you've seen before. And what we're going to do is we're going to graph these 4 inequalities. And then what we're going to do is I'm going to teach you a way to notate your answers that you can use the graph as a visual to build. So when I go to graph, x is greater than or equal to 2. Here's my number line. X is greater than or equal to 2. On my graph, what's the number that matters on that graph? 2. Okay, 2, that's the reference point. Okay, so I'm just going to put a little mark here, and I'm going to label it 2. If you want to put other marks, that's fine, but I'm a minimalist, so we're just going to have that. So I have 2 questions for you. First, If all my values, all my x's are bigger than or equal to 2, which way am I going to shade? Which way are the points? Are they on the left side of that or are they on the right side of that? Right. They're on the right. The number line gets bigger the further right that you go. So I'm going to shade like this, that these are my values. I'm going to put a little arrow on the end because the values go on forever and ever. What do I put at 2? Since I have x is greater than or equal to 2, how do I designate my starting point? Anybody remember that? It's a form of a circle. Your choice is an open circle or a filled-in circle. Which one do you think is going to represent that I have equality, that 2 matters to this graph? Okay, well then I'll help you out. We're going to use a filled-in circle. Filled-in circle means that 2 is my point of equality. That's part of the graph. I need it, and then everything is bigger. So what I would like you to do, please, is do your best hypothesis. Graph x is strictly bigger than 6. Okay, this time I have no equal, so what I put at the value is going to be a little bit different than that graph right there. So what's the point that matters on this graph? What's the only value that is my reference point? 6. Yes, indeed. So I'm just going to put a little mark there. I'm going to label that 6. Once again, on my number line, if all of my values are going to be bigger than 6, am I going to shade to the left or am I going to shade to the right? Which way is bigger? To the right. Right is always bigger on the number line. That will never change. That will never be a trick question. Okay, the number line gets bigger the further right you go. The number line gets smaller the further left you go every time. This time, though, I'm not interested in equality, so I'm going to use the other option to notate my endpoint. I am going to do an open circle. An open circle says that that is where we start, but it's not included in the set. So like 6.01, that's bigger than 6, so it's shaded. 6.05 is bigger and it's shaded, but 6 is not part of my values right there. All right, this inequality that has bounds on both sides. So this time I have a lower end to this interval and I have an upper end to this interval. So I'm going to label both of those points. I'm going to put a mark here for -6 and I'm going to put a mark here for 14. Again, our points always get bigger the further right you go. That's why I put the 14 to the right. The 14 would never go on the left side of the -6. This inequality tells me that all of my values are bigger than -6 and less than 14, so I'm going to shade in between. So using what we've already seen, in case you haven't seen this before, what am I going to put at the -6 side? Am I going to put an open circle or a filled-in circle? Open. There's no equality right there. Perfect. Open circle. What am I going to put at the 14 side to this one? A filled in or a closed circle, because there is an equality. There is equality there, so I fill that one in. Please graph this last one, and then I will tell you why we are graphing things. Okay, my 0 and my 9, those are my ends. So I put a 0 and a 9 here. Again, the numbers get bigger the further right you go. This inequality says my x's are bigger than 0, and at the same time they're less than 9. So that's how I indicate I shade in between. What am I going to put on each of my endpoints on this particular problem? Filled in circle, both times. Yes. Right here, starting and stopping point. Okay. So I'm hoping you've seen that at some point. I'm not getting super good feedback that you have, because this is something that I'm assuming is going to be one of the things you know how to do. So if it's not, we need to talk outside of class. Okay, so the reason I did this though is so we would have a visual to learn this. This is the thing that I want to deal with today. Something called interval notation. I don't want to have to graph my answers to these inequalities. I want to write down and I want to communicate the interval in a more mathematical way. So the way you write anything in interval notation goes like this. Okay, you have a lower limit or a lower bound, then a comma. Then you have an upper value or an upper limit. Probably value is better. Let me change the word limit to value. I think that's more understandable. A lower value, an upper value. And then on each side, depending on if the point is included, if there's equality or not, you're either going to use a bracket. What a bracket stands for is equals. Or you're going to use a parenthesis. What a parenthesis stands for is that there's no equal sign. That's your choice. It's analogous to our dot or our filled in circle and our open circle. So I'm going to start with our middle two examples because I think they're a little bit more straightforward. So on this graph right here, looking at the picture, what is the lowest value of this graph? -6. Perfect. That's not a good pen. We will not use it. Try this one. Negative. That's a little better. -6. What is the highest value on this graph? 14. Indeed. The graph does not go any further than 14. And so at the -6 end of this, since I do not have equality, according to what I've written up there, what am I going to put at the -6 end of this interval? Is it going to be a bracket or is it going to be a parenthesis? Is there an equal sign underneath this less than sign? No. So when there's no equal sign, we're going to use a parenthesis. So I'm going to put a parenthesis on this end, like that. On the 14 end, is there an equal sign on the 14 end? Yes. So what am I going to put at the 14 end of this? Put a bracket. And there's my interval. That communicates that all of my values, my solutions, when we're solving an inequality, they start at -6 and they go to 14. -6 is not part of the answer. 14 is part of the answer. This one right here, 0 to 9. Write that in interval notation, please. What's the lower end of this interval right here? 0, the lowest. What's the highest value on this interval? 9. What am I going to put at the 0 end according to what this says right here? Bracket, because there's equals. What am I going to put at the 9 end because of this right here? Bracket, because of equal. Fantastic. That's the interval notation. Tells me that all my values go from 0 to 9, and they include those two values on the end. So what do I do now when I have an interval that doesn't have one of the ends? Okay, this is all my values are bigger than 2, and it doesn't say that there's ever any stopping point to this. Okay, so how do I do this? All right. Well, according to my graph, here's my 2. Is 2 the smallest or the lowest value on this graph, or is 2 the biggest value on this graph? It's the smallest. There's nothing else down here. There's nothing lower. The number line gets smaller the further left you go. Left is less. Okay, so 2 is the lower part. Now, I need to communicate to people that are reading this that my interval never stops, that there's no highest value. And so the way that we do that is we got a symbol, and it is the infinity symbol. The infinity symbol is different than the car. Okay, the infinity symbol is like an 8 that's had too much to drink on Friday. Okay, it's laying on its side. And there's my infinity symbol. Infinity is a direction, not a destination. You can't get to infinity. Okay, so infinity, this is a direction. It's telling me that the values never stop. So for this one, what am I going to put at the 2 end to this interval? I've got an equal. I'm going to put a bracket. Yes, indeed. So I put a bracket here. At the infinity side, because you can never reach infinity, okay? It's not a place that you stop. Okay, always and every time, no matter what. It does not matter that there's an equal sign here at all. You always use a parenthesis at infinity. So I'm just going to put a little asterisk here and say we always use a parenthesis. I don't know how to spell parentheses, so that's the best I can do. No spell check on the whiteboard. Once you've written that down, do this one. X greater than 6. The only difference to this one that you have to sort through is that there's no equal at the 6 this time. Where the 6 is and where I'm shading, all of my values, all the things that I'm looking for, the X's are bigger than 6. So we shaded on the bigger side. So does that make 6? Is that the lowest value or is that the highest value? The lowest. Does my interval ever stop? Am I given a point up here that I get to and I stop and I'm done? So what am I going to put on the upper end of this interval? Infinity. You never get there. There's no equality. So what am I putting at the 6th part of this interval? Not a bracket. We have no equals. When you have no equals, you put a parenthesis. What do I always, every time, every day put for the infinity end? Thank you. A parenthesis. And that's my interval. That says the interval starts at 6 and it goes forever in that direction. All right, well, here's a few more examples of interval notation. Then we will do some solving. So that's my next example. X is less than -1. X is less than or equal to 10. And then I promised you at the end of last time, I know you've been waiting with great anticipation. I'm going to tell you how to write all real numbers. First thing I'm going to do, just like last time, is we're going to graph these so that we have a picture to go from in order to write our intervals down. Okay, so the first thing, X is less than -1. So once again, -1 is the only value that matters. It's the only value I see on my statement right there. This time, though, it says all of my x's, all of the numbers that I'm looking for and don't know, they are less than -1. Okay, they are below -1. So which way on the number line, left or right, represents being less than -1? Left, yes. This question is the same question I've asked a few other times. What am I going to put at the -1? Open circle, because there's no equality, there's no equal sign right there. So I put an open circle. There we go. So graph this one. X is less than or equal to 10. On this graph, 10 is the only value that matters, so I'm just going to put a mark there for 10. This time, all of my values are less than or equal to 10. So just like the previous problem, less than means lower, so it means left. There's my shading. But unlike the previous problem, what am I going to put at the 10 side? I'm going to fill the circle in because there's the equal sign. Okay, that's information, that's telling me what to do. We'll come back, we're going to write these in intervals in just a minute. The last one, all real numbers, the graph of this, since it's everything, all real numbers means a whole number line. So I'm just going to shade the whole thing. So one of your jobs when you go through the homework is there's going to be problems to help you get familiar with interval notation. Okay, this is how you are going to notate your answers to me when you solve the inequalities that we're going to learn to solve in a few minutes. Okay, so this is I don't know if this seems reasonable to you or unreasonable, but this is the thing that I'm going to be expecting. So it's good to be familiar with it. So on this problem right here, we said that all of my values are less than -1. They're all lower than. So here's the graph. So according to the graph, the -1, is that the lowest possible value or is that the highest possible value? This time it's the highest value. Okay, there's nothing bigger. So it's going to come after the comma. Exactly. Again, infinity is a direction, but we're not going in the positive direction. We're going backwards. We're going in the negative direction. So to let everybody that's looking at this know, I'm going to put a negative in front of my infinity, and that means I'm going backwards as far as possible. Same question as before. What am I always and every time going to put at the infinity end of an interval? Parenthesis. That's never going to change. There's no tricks there. According to the sign up at the top, what am I going to put at the -1 end of this interval? Parenthesis again. There's my interval. Parentheses tell you there's no equal sign. So do me a favor, try your best. I'm going to give you 20 seconds. Write down what you think the interval is for x is less than or equal to 10. So looking at the picture, what's the lowest value on this graph? Negative infinity. Yes, there is no lowest value. It goes forever and ever to the left. What's the upper value? What's the highest value? Yep. I always put a parenthesis at the infinity end. This time, because of the sign that's used between the x and the 10, what am I going to put here on this end?
A bracket.
A bracket. Always with equals, you put a bracket. The last one, all real numbers. So when we have a problem that everything is a solution that represents every number on the number line, well, this is how we write this. Looking at the number line, what is the lowest value if it's all numbers? Negative infinity. What's going to be the highest value if it's all real numbers? And then always and every time, no matter what, you put a parenthesis on each side. We'll talk a little bit more about interval notation because, like I said, we're going to be using this to write our answer to every problem. Now, I am not going to graph every time, but that's your tool. If you're just catching on, or if you haven't seen this before, then this can be a good step for you to write down the proper interval. Okay, so if you need to write this graph, that's great, but I'm not going to be doing it every time. So now, my big thing today, interval notation, that is our tool to write down the answers. That's, I think, the new thing for the day. I'm hoping this next part is familiar and nice and not new. We're going to solve some inequalities. This is the same thing that we did last time. There's only one tiny little difference when I'm solving an inequality versus an equation. Okay, so we spent 90 minutes last time on Monday solving equations. So we're going to use those same skills to solve inequalities. So I'm going to give you this one, and I want you to, well, no, we'll do it together. So here we go. X minus 7 is greater than 10. The process is no different for solving an inequality. If I've got to get the x by itself, what do I have to move? The -7. How am I going to move that -7? I'm going to add it. Yeah, indeed. We do the opposite. Okay, hopefully you logged into my math lab and you maybe did a few homework problems. Okay, remember, if you don't have your money, if you don't have your financial aid, or if you haven't gotten paid yet, you can do a free 14-day trial. I can help you get there. So don't let anything stop you. Practicing is important. So the 7s cancel, and I've got x. 10 and 7 is 17. And then I just drop the sign down, and it's greater than. So it says my x's, my solutions to this are all bigger than 17. Now, if you need to, while we're writing the interval notation, you can real quick and scribble a graph down so that you can see what my interval is. But if I'm telling you all of my values are bigger than 17, everything is bigger than 17, is 17 the low end of the interval, or is it the high end of the interval? It's the low end. Great. And so since I'm not given a high end, I'm going to put an infinity there. And again, if that's not clear to you, draw your graph like we did on the previous ones so that your brain will start to link these things together. At infinity, I always put a parenthesis. And on this particular problem, because of the sign right here, what am I going to put at the 17 end? Parentheses as well. Yes, indeed. So here's one for you. Same sort of thing, nice relaxing problem. Something to make you happy. You got out of bed today, came to class. X plus 8 is less than or equal to, let's go, -2. So I want you to solve that, and then I want you to write the answer in interval notation, please. Thinking ahead though, I love it. It's a good question. Okay, so if I'm going to solve this, what do I have to move? The 8. How am I going to move it? Subtraction. You always just do the reverse. This is +8, so the reverse of adding 8 is to subtract 8. It's always that way, just like with equations. So I have x. I'm going to bring down the less than or equal to. The question was, hey, Perkster, I know there's a time when I flip the sign. Is this it? Not yet. We're going to talk about that next thing. Okay, so some of you've seen this before, and it's a fuzzy memory. You're just about to get there. So -2 and -8 is -10. So this is a less than or equal to. So this says all of my values, every one that I have is going to be less than or going to be below -10. So if everything is below -10, is -10 the smallest value, or will -10 be the highest value? Highest. If everything is below that, -10 is the highest value. I'm not given a lowest end of this interval, so -infinity. I always and every time, no tricks, no gimmicks, put a parenthesis at the infinity end. And this time, what am I going to put according to the sign at the -10 end? Perfect, thank you. Love the confidence. All right. So my whole point here, starting with these examples, is just to show you that the stuff we learned on Monday, or the stuff we practiced or relearned or reminded ourselves about, is still in play. Here's the one difference. Okay, so here's my demonstration. It's been a while, you might know. There's one little thing you have to remember. There's one difference solving an inequality versus an equation. And I'm going to show you what that is right now. Okay, so let's say this. -4 is less than 4. Is this a true statement or is this a false statement? Is -4 less than 4? That's true. So here's what we're going to do with that true statement. I'm just going to draw a line here. I'm going to separate it. Here's what we're going to do. We're going to multiply both sides of that by 5. Okay. Why 5? Just because that was the first number that popped in my head. There's nothing special about it. Okay, we're going to multiply both sides by 5. What do I get when I multiply -4 by 5? What does that become? What do I get when I multiply 4 by 5? What does this side become? Does the same sign still fit? If I put a less than here, does the same sign still fit? It's -20. Is -20 still less than +20? Yes, I'm looking for more confidence. I got a couple confident people. So it's still the same sign. Well, that wasn't really an interesting demonstration. You're thinking you're wasting my time, Brookster. So here's what we're going to do. We're going to multiply by, let's change it. Instead of 5, we're going to multiply by -5. Let's see what happens. And this is where we're going to encounter what you were anticipating. When I multiply by -5, what do I get on this side when I multiply by -5? What's -4 times -5? 20. On the other side, what's 4 times -5? -20. So here's the $100 question. Does the same sign still fit? If I put a, don't write this down, if I put a less than sign, is that a true statement? Is 20 less than -20? No. So what do I have to do here to make a true statement? Okay, I've got to flip the sign. And that is, to summarize, the one difference. Okay, this is the thing to remember. Okay, if you hated the demonstration, that's fine. Okay, but this is the thing that you need to remember when it comes to your homework and quiz and test. Okay, so here it is. If you multiply or divide both sides if you multiply or divide both sides of an inequality by a negative, okay, I've put a box around the negative. That is the key word here. Then you must flip the inequality sign. It's non-negotiable. That's the new bit of information solving inequalities. Okay, so once you've got that written down, here's my next example. I've got an example, and then I'm going to have you do 2 or 3 or 4 because the process is exactly the same as solving equations. There's no difference other than this one thing. So here goes. Negative 3x plus 8 is greater than or equal to 23. So what's the first thing that I need to move here? The 8. How do I move the 8? Subtract. Just do the reverse all the time. Okay, so I'm subtracting 8 from both sides. Well said. I love it. Negative 3x. The 8's cancel. 23 minus 8 is 15. Does adding or subtracting? Does adding or subtracting make me flip the sign? Only multiplying or dividing by a negative. That's the only time. Adding or subtracting, we're fine. Okay, so we leave the same sign. Now, Mr. Perkins, I see that I got a negative 3. Should I flip it now? No. Because what happens, what I see students do all the time is if you pre-flip, right, because you notice it, then you're going to end up flipping again. Okay, and you end up with the wrong sign. I see it all the time. So just wait. Hold off until you actually do the division. Okay, so now what I'm going to do of negative 3 times x, so I'm going to divide by that negative 3. That's the key right here. Okay, I'm going to put a little arrow. That negative 3, that is the key. It does not matter what the sign of the 15 is. That is immaterial. It's what you divide by. And so a negative divided by negative is x. 15 divided by negative 3 is negative 5. And since I divided by a negative, what's my new sign? Less than or equal to? You got to flip it. Okay, so we have to flip the sign. For the last bit, interval notation, all of my values have to be less than or equal to negative 5. So if everything is less than, if everything's below negative 5, that means negative 5 is the bottom or top? Top. Everything else is below, negative infinity. Always a parenthesis at the infinity side. And since I have the equality, I put a bracket there. All right, here's one just like that for you. Okay, I want you to get your feet wet doing this. So let's have this. Let's have 9 minus 4x is equal to, let's say, 33. 9 minus 4x is equal to 33. What's the first thing to move? The 9, yes. Do not combine these. These are not like terms. It's not 9 minus 4 is 5x. Okay, this does not have an x, that does, so you cannot merge them together. So I need to move the 9, I'm going to subtract it. What's the term? Oops, I gave you equal. Good job, Brewster. You're an amazing professor. Well, I'll give you a moment. Now that you've solved that, this next problem will be super easy. So try this one. Let's do a strictly less than then. Okay, sorry about that. Okay, so you already solved the other one. The steps are the same. We just got that one little issue with the sign. So you already told me to move the 9 first. So I'm going to keep doing that. And so the 9s cancel. What's the term that remains on the left? Yeah, don't forget that -4. That's why I asked the question. Those details matter. And then 33 minus 9, that's 24. And then I'm just going to ask this question again because I just want to make sure that we're sinking in here. Does subtraction make me flip the sign? Nope, the subtraction does not. So it's still a less than. Then my second step is going to be divide both sides by -4. And so we've got x. 24 divided by -4 is -6. And why am I flipping the sign here? Because I divided by negative. If you divide by a positive, you don't flip the sign. Okay, only when you divide by a negative. So now it becomes greater than. So this is all my values are bigger than 6. Everything is above 6. So because of that, or above -6, because of that, -6 is the lower end of the interval. Everything else is above that, so greater than. And what am I going to put at the -6 end of this interval? Parentheses. There's no equality there, so parentheses. Here's another problem. I will remember to put the inequality sign between the two sides. Let's try this. Let's say that we have 3x plus 13, and that's going to be less than or equal to 5x minus 11. I am going to, because it's my way, I am going to put the x's on the left. If you choose to do something else, it's fine. I will show you that we get the exact same answer no matter what. Okay, so do it how you want, but I'm going to be putting x's on the left. All right, so x is on the left, numbers on the right, and then I will divide. If you put the x's on the right because you see that you're going to end up with like some students say the 5 is bigger, so I'm going to put on everything on the right. That is a totally great mindset. Just going to show you, I'll do this both ways and show you we get the same thing either way you do it. But the way I do it is I put the x's on the left, so I'm going to subtract 5x. 3x minus 5x is -2. I haven't done anything with the 13. I've got a -11 over here. I've subtracted, so the sign stays the same, no different. I'm going to subtract the 13 now. And again, 2x, the 13s cancel. I've subtracted, so the sign stays the same. And -11, -13 is -24. Last but not least, I'm going to divide by -2. And so I've got x. -24 divided by -2 is 12. And since I divided by a negative, I have to flip the less than or equal to sign to greater than or equal to. And we'll write that in interval notation in just a minute. But I just want to show you, demonstrate for you, so that you have confidence in case you wanted to do it the other way and you just did it my way because I said that's what I was going to do. Okay, I'm going to do this by putting the x's on the right, okay, if that is your habit. So if I put the x's on the right, that means I'm subtracting 3x. So I've got 13 over here. Since I've subtracted, it's still less than or equal to 5 minus 3 is 2x minus 11. I'm now going to put the 11 on this side. 13 and 11 is 24. I've added this time, so the sign stays the same, and the 11s cancel. Now notice here, the statement that if you did it this way and the statement that I had are pretty similar, just the signs are different and they're on different sides. So notice this time when I divide by 2, I'm dividing by a positive. I don't flip the sign when I do it this way. So 24 divided by 2 is 12. 2x divided by 2 is x. I keep the sign because that's a positive 2. I know that your x there is on the other side, but we have the same thing. And this is a recommendation of mine. If you ever solve an equation and the x is on the right like this, and now you're going to go graph it or put it in interval notation, my recommendation is to rewrite it. Because what I find is, and I do the same thing, when students see this, you see the less than and you see less. But we always have to read our inequality from the perspective of the x. So what I would say to do is do this. I'm going to say, put the x over here and put the 12 over here. And then remember the pointy part is pointing at the 12. The pointy part's pointing at the 12, so my pointy part is pointing at the 12. And notice we've got the exact same inequality when I reflect it. Yes, sir.
Yeah, so what's the reason that you put the sign? Like when you divided it, why do you have to put the sign? Or what's the reason behind it?
The reason is that demonstration I did right here before, that multiplying by the negative reverses the values. So when I had -4 is less than 4, that's a true statement. But now when I multiply both sides by a -5, so I'm just going to multiply everything by a -5, what happens now is it reverses the signs and changes the truth value of this. So on the left side, I have a negative times a negative, that makes a positive 20. That's now going to be the bigger side. And so since that's the bigger side, I had to flip the sign to reflect that. Okay, that's the reason. So then the learning out of that is, in general, anytime you divide or multiply, because they're equivalent operations, anytime you divide or multiply by a negative, you have to flip that sign because what happened there is happening here too. Okay, that's the reason. All right. Great question. Great. Oh, we need to write this in interval notation. All of my values are bigger than 12. So if everything is above 12, that means 12 is the lowest value. And everything above it is infinity. Parenthesis at the infinity end. And since I have equals, I put a bracket at the 12 end. Here's, I've got 2 more problems, and then we are going to be done with this section. So let's try this problem. I've got -3 times x plus 4 in parentheses, then plus 2 is greater than or equal to 7 minus x. So solve that and write your answer in interval notation, please. I'm going to get started. You keep working if you're still working, okay? And we'll meet up at the end. So again, just like with our equations, process is absolutely no different. First thing I'm going to do is I'm going to distribute. So -3 times x is -3x. -3 times 4 is -12. Then I have +2. Now that's distributing. I've not done anything to both sides of the equation, so I don't flip this sign. There's no reason to. I'm going to collect my like terms next. So I've got a -12 plus 2, that's -10. Again, all of this is the same stuff we did for an hour and a half last time. Now I'm going to put all of my x's on the left, all our numbers on the right. If you did the reverse, we will end up in the exact same place. So I'm going to add x to both sides. And when I do that, -3 plus 1 is -2x. I have added, so that does not flip my sign. Add 10. Again, -2x. I have added, so I don't flip the sign. My last step, since I have a -2, when I do something, when I multiply or divide a negative on both sides of the inequality, it changes the size relationship of the values. And so I have to now flip this. Instead of a greater than or equal to, it becomes a less than or equal to. 17 over -2, you're welcome to make that -8.5. If you love decimals, I'm going to just leave it as 17 over 2. This says all of my answers, all of my values are less than that. They're all below that. So that means -17 over 2, that is the highest value. Everything being below that is -infinity. And I have a bracket on that. Here's our last problem from this section. And then we're going to begin section 2.1. So the last problem is this. 5 minus 2, then parentheses, x minus 4, less than or equal to 11 minus 4x. Solve that. Write your answer in interval notation, please. All right, so let's finish this up. First thing I have to do is distribute. We mentioned this same thing on Monday. I'm going to mention it again because it's one of the most common mistakes. You do not do the 5 minus 2 and get 3. That would be doing your subtraction before multiplication. That violates the order of operations. So I have to distribute first. So I have 5, and then negative 2 times x is negative 2x. Negative 2 times negative 4 is plus 8. I'm going to collect these like terms. So I have negative 2x. 5 plus 8 is 13. I'm going to put my x's on the left, my numbers on the right. So I'm going to add 4x to both sides on this one. Negative 2 plus 4 is 2x. I have added, so I don't flip the sign. I'm going to subtract 13 from both sides. I've subtracted this time, so I don't flip the signs. And 11 minus 13 is negative 2. And then last but not least, this is the first time it's happened because I've been focusing on our new thing, but I'm dividing by a positive 2. So do I flip the sign on this problem right here? Nope. Stays the same. Doesn't matter that there's a negative 1 on the other side. That's immaterial to flipping the sign. And then last time, all of my values are below that. So that means that negative 1 is the highest part of the interval. Everything being below it is negative infinity. Parenthesis, because of the equals, I put a bracket on that end. Ooh, I just got that in on the screen too. So if you watch the video, you can be impressed at my management of it. Okay.